Hi, my name is Amy Baloy, and today I'm going to be presenting our product, the Brush Box, on behalf of Team 7. So I'm going to start with a brief recap of our past design presentations, which includes a description of our product, the Brush Box, our target audience, customer needs, our specifications in decomposition, as well as the concept generation and selection process. So we came up with our idea during the boil water advisory here at Virginia Tech. We noticed that it was difficult to maintain the hygiene of not only ourselves, but our products that we use to clean ourselves, including our toothbrush. So essentially our product is designed to dry and sanitize a toothbrush, as well as create its own storing compartment and mounting solution. So this is our customer profile. We decided that the average student needs this product, and the average student is defined here as someone that is typically unclean or learning to live on their own for the first time and lives in a dorm or near a sink and brushes their teeth on a daily basis. Our use profile outlines the general flow of the product, and the average customer loves this idea. So we interviewed 2 potential customers each, totaling out to 8 customers, and we asked them what they think about our product, what they think about the typical uses, any dislikes of what they are hearing, and any suggested improvements of our product. And each customer was required to be a Virginia Tech student and performs daily dental hygiene. We turned their customer statements into interpreted needs, and those interpreted needs were put into our survey here, outlining the different features we want to see on our product. And we ranked them on a scale of 1 to 5, 5 being a critical feature that we would like to see on our product, and also decided if they were unique, exciting, and or unexpected. This is our initial sketch and specifications. As you can see, it's a very rough sketch of what we had in mind for our design and a very rough approximation of our specs. So we created this sub-function chart, which outlines the different functions of our product and the different components that could be used under each sub-function. So it outlines the different options that we had. And from this, we created our concept combination table to choose our best solution. So each member was required to create a line down the chart that will essentially turn into a solution, and we required to do 2 each. And our solutions were then made into sketches. From here, you can see that each member had 2 designs, and we outlined which designs we made according to which solution, and created sketches to go along with them. And these sketches were then turned into CAD models on the NX software, as you can see here. And we related how our CAD models support our customer needs statements. We essentially ended up going with Andrew's design for our final prototype because his product has the highest line density on the concept combination table. So breaking down his design, these are the different components required to assemble his design, his final solution, and we call this the functional decomposition table. So we searched up the different related patents to our device to ensure that nothing would hinder our design product, and we found that none of them do. Well, as far as the ones that we researched, they have since been expired as a patent, with the earliest one being from 1922. And from what we gained from this research is just possible ideas for future iterations of our product. Our FMEA table, so our failure modes and effects analysis table, we decided to consider any possible way that our product may fail, and decided to find ways to prevent that. And you can see the results of it in this table here. DFM and DFA. So we designed for manufacturing, we designed for assembly. Essentially, we took apart our product and put it back together and timed ourselves to see how long it would take to manufacture and assemble. And we did this several times to create a learning curve of 10%, and our assembly time is at 104.5 seconds. We estimate that if we pay our factory workers an average of $17 per hour, the wage cost would come down to right below 50 cents per unit. This is our updated economic analysis, and we determined that our new findings work to our benefit because our break-even line has shifted down the demand line, and we are at a break-even point of 415 units. And the purchase cost was adjusted to $45. This is a breakdown of our total costs. So each component from the functional decomposition table is listed here, and we noted how much each component is going to cost, and it comes out to a total cost of $52.03. So CADing the final prototype. This is the final CAD as made by Andrew Carella, and rough drawings of each side of the box. We decided to curve the edges so that it is smooth and for customer pleasure, and we created a panel here to hide any electronic devices in the background so that one, they don't get wet, and two, it protects the wires from customer eye. And the motor mount here is at an angle to allow for better airflow, and there are 3 holes here for several toothbrush insertion. This is a picture of our final prototype. The outer box here, the inner panels, and the motor mount was 3D printed here at Virginia Tech. The door was cut from an acrylic material using a vertical bandsaw, and the inner parts were all assembled by the team members for functionality. So you put the toothbrush in, close the door, click the button, and the device turns on. A yellow light will flash to indicate that it's working, and the green light will come on to let you know that the toothbrush is done and clean and dry. So reflections on product improvement. We decided that if we were to have more time, the overall project would have gone a little smoother, considering that it is a motor and microcontroller device. For example, we ordered parts well in advance, but can't trust shipping, and they're still on their way. And we would have been able to have time to really trial and error and consider the different ways that our device could fail, so further our FMEA analysis, and been able to adjust the tolerances and figure out our locations for the electronic devices, and relocate certain things, like maybe move all of the electronic parts to a focal area and maybe move the button to somewhere reachable, things like that. But these are ideas for future iterations of our device. However, why will you love the BrushBox? Because it has functional development, careful considerations for design, detailed modeling and simulation, importance applications, and environmental, social, and cultural impacts. It is a device that is meant to assist you on a day-to-day basis so that you do not need to think about the hygiene of your toothbrush and where to put your toothbrush and how to keep it clean and all those factors. So if you have any questions, please reach out. But that is all we have for today, and I thank you for watching.